Hello everyone, and welcome to today's webinar. I've given it the somewhat unassuming title of Selecting from Arrays, and I suppose in other languages maybe this is a bit harsh, it would be like a page on a tutorial, but obviously in a language like APL, where arrays are your first class citizens, there's going to be a bit more to talk about. So, while the beginning of
Hello
this...
everyone, and welcome
my
to
days.
today's webinar.
Why is that
I've
playing
given
back?
it the somewhat unassuming title
Okay,
of
I'm going to have to... My sincerest apologies for that. I was testing the audio earlier and had Dyalog.tv open, which I'll come back to in a second. But, as I was saying, the audience, especially for the first part of this, is going to be mainly beginners, people new to APL and starting to learn the sort of array-oriented way. But experienced APLers will also, I think, benefit from the discussion on the array model, and also later on I'm going to introduce some modern indexing constructs, some indexing functions which use the rank operator. Now, I just had a bit of a slip up there because I was testing Dyalog.tv. If you are watching on Dyalog.tv, my colleague Matt is in the chat, and he's happy to talk to you throughout this, and he will also relay any comments and questions you have to me, so I'll be able to respond with about a 30-second delay. So, as an overview, I'm going to be introducing the sort of three main, indexing regimes: simple, choose, and reach indexing. And then later, I'll talk about the rank operator and use that to create some, use that in some modern indexing functions. So, simple, choose, and reach indexing have been in Dyalog for a while. Reach is more to do with nested arrays. They are supported by a special syntactic element, special syntax, which is the square brackets. So these all work with square brackets. A couple of them also work with other functions, but they will all be accessible through square brackets. And more than that, they also allow you to do some very useful things, such as indexed assignment, so we can modify the elements of particular indices. Modified assignment, which is similar, but with modifying values in place. And also these methods of indexing are fast. At least compared to some of the, or at least one of the functions that I'm going to introduce a bit later on. So to start with, just to make sure we're all on the same page, I'm going to sort of define some terminology, because especially when it comes to, I think, the word elements, and for some terminology, APLers can play a bit fast and loose, and so it helps to have certain definitions that we can use. So for an example to help illustrate these concepts, I'm taking a 3-dimensional array made out of the alphabet, and as a 3D array, it obviously has 3 dimensions. We can also say it has 3 axes, where the first axis sort of has the major cells, the matrices. The 2 matrices lie along the first axis. and then your 3 rows of each matrix lie along the second axis, and the 4 scalars of each row lie along the third axis. Apologies for that as well. Someone's just rung the doorbell, but I think my partner will attend to that. So, okay, cool. Continuing on. So, for any array, the major cells are the rank -1 cells. So, for our example 3D array, our major cells are 2 cells, or matrices, and there are 2 of these. Each of these matrices has 3 1 cells contained within, and those can also be referred to as the rows of a matrix or vectors. And then we have 4 0 cells or scalars in each of those. So that's kind of the terminology from that, sort of talking about the axes of arrays and the cells of arrays. I'll come to subarrays in a moment, and elements I'm going to use to refer to the thing inside a scalar. So if it's a nested array, it'll be the array contained inside a scalar element, a scalar 0 cell, sorry. So this is why I'm trying to define the terms. But yeah, that'll become relevant later. So first of all, let's start with the basics and talk about simple indexing, although we are going to be talking about high rank from the off. So this is, indexing into a 3-dimensional array, and with square brackets, which you learn quite early on in APL. The one awkward thing is that you have to know in advance what the rank of the array you're indexing into is, so that you can provide the square brackets with the correct number of semicolons, or else you'll get a rank error. The squad indexing function alleviates this. It just says, if you give me a singleton argument, I'm going to select, that nth major cell. We can, then index along each successive axis in square brackets. So here I want the second row from the first matrix. And here's the same thing with squad, the indexing function. And similarly for indexing into a scalar. So, it's not just grabbing cells that you can do. You can also select what I'm going to refer to as subarrays. And although it might technically be more general a term than this, I'll use the word subarray to refer to these sorts of selections of elements which are rectangular in shape when you pull them out. And so that means, it doesn't have to just be a contiguous subarray like this one is, where all the cells are kind of next to each other in the structure. You could also have non-contiguous subarrays and select them. But the overall shape that you'll get out is still going to be rectangular, like any array. I'm now going to switch over to, from this 3D representation to the representation that you get, in the session, just to introduce, or just to talk about the next 2 forms of indexing. So here's the same simple indexing. Then there's choose indexing. And so instead of selecting along each axis separated by semicolons, with choose indexing, you select using a non-simple array. So in this case, we have a nested vector of numeric vectors, and each index within is a full index into our array. And by full index, what I mean is the length of each index is the rank of our array. So select individual scalars this way. Then there's reach indexing, which is a type of indexing specifically geared towards reaching into nested arrays and pulling elements out. In the simplest case, when you're indexing into that first sort of depth, that first layer, it's the same as choose indexing, but we also have the ability to reach deeper inside successive layers, and we get the scalars within, right? Note that the scalars we retrieve using brackets with reach indexing are still scalars, as in, any nested array is enclosed. Obviously, this is a bit of a gotcha for beginners, where scalars are the enclosers of themselves, and so you won't see the boxing if you get that deep. Also, unlike simple indexing, it doesn't just translate directly to squad. To be fair, nor does choose indexing. If you want to use reach indexing without square brackets, but you want to use a function instead, you can use the pick function, which is the right shoe here. And this will not only reach in and grab your scalar, but it will also unpack the scalar and provide you with the array. To be honest, most of the time with pick, this is how I use it. I'll have a nested vector of text vectors, which maybe refer to some options or something, and I do care about the value of the element inside, so I'm going to use pick like this. So those are kind of three main indexing constructs. We have simple indexing to select subarrays. We have choose indexing, which lets us grab the scalars, and reach indexing, which is useful for nested arrays. So that's so that's your basic indexing introduction. Now I would like to talk about squad. So squad, the primitive, the glyph, the symbol, the squished quad, is actually made of, it's the square brackets overstruck on top of each other. So that's where the symbol comes from. And what it is in Dyalog APL is the indexing function. And because it's a function, like a normal function like any other, you can use operators. And this allows us to construct some slightly novel indexing constructs, a couple of which are particularly useful, and I'll show you now. But just before I show you those, I'd like to again sort of give an overview of this sort of contrast between the axis view of arrays and the sort of cells or function rank view of arrays, because squad can be used with, and I'm going to show you lots of examples using the rank operator, but it can also be used with this square bracket axis operator. And I use operator in air quotes because it's not a general operator like rank or each or reduction. It's special syntax which only applies to certain functions, and squad happens to be one of them. So you can see in this example, squad rank 2 happens to give, for this example, an equivalent selection to squad on the second axis. However, I'll now demonstrate kind of the main differences between these approaches. So by default, if we'd omitted the bracket 1, we index along the first axis, and this means selecting the second major cell, or the second matrix of our 3D array. This is equivalent to, or this is the same selection for this example as squad rank 3, where we're essentially selecting the second major cell from each 3 cell. And for this example, the whole array happens to be a 3D array, so we're selecting the second major cell. So again, this would be the same as, say, squad rank 99, which I'll explain in a second. Along the second axis, we're now selecting rows in our example, or you can kind of think of them in this model as layers, right? So select the second layer. This happens to be equivalent to squad rank 2, but the model is, starting to see the difference more now. Here, we're looping over each 2 cell and say for each matrix, give me the second 1 cell, give me the second vector. So for the first matrix, we select the second row, and then for the second matrix, select the second row. And this becomes even more clear when we look at the third axis, right? So we're selecting from columns, selecting the second column, or you can sort of imagine these slices. It gets harder as you go up the dimensions to imagine the geometric sort of array like this, array structure. But the equivalent rank selection, or selection using rank, is index rank 1. And so here, yes, we're looping over every row and indexing into the second scalar on each row. So conceptually, they're kind of different. And while rank is technically and in general a loop, I believe squad rank 0k, which is kind of what this is equivalent to, right? I've given it a scalar on the left and some rank on the right. This is special cased in Dyalog, so it isn't actually in practice slower than doing an equivalent selection using traditional indexing methods. There are other cool things that you can do with the rank operator and indexing, and here's one of those. So this one is selecting disparate major cells, not necessarily contiguous or even related by any pattern. Just select these. Give me the first, third, and fourth row from my matrix. So what this statement is saying is select from each 2 cell in n, and n happens to be a whole 2 cell, so just the whole array, using each 0 cell on the left. So you loop over each scalar on the left. So this is equivalent to doing like mix 1 squad n brackets 3 squad n brackets 4 squad n, but we can do it in one statement like this. You'll also notice that I've chosen in this example to use the maximum rank of our right argument array. So it's a rank 2 array, and I'm doing squad rank 0.2. If you want a general tool that lets you do this type of indexing on any rank array, just give me the nth major cells for all of my indices on the left. Maybe I shouldn't have used nth there for this example. But you can simply replace the 2 with a 99. And yes, the 99 is arbitrary, and it is based on the assumption that we're not going to implement arrays of rank higher than 99, certainly not before we implement an infinity in Dyalog. But, it works with any rank array, and you don't have to keep redefining based on the specific rank. And if this whole construct is too ugly to look at for you, you can always name it. And in some circles, they've taken to calling this sane indexing. I suppose the reason being that this version is right, having to enclose your argument to select particular major cells. To be sure, it's a bit prettier. I have a comment about the right tack, and I'm supposing I have to find out. So right tack is basically separating the numeric operands to rank from the sort of argument array. So 1, 3, 4 squad rank 99, right. So let's hope I've got n in here. And if we look at, sorry, not the status bar, toolbar, we're going to zoom in a bit to make it easier to see. So I was doing 1, 3, 4 I really apologize. Matt is going to have to tell me if I'm back, because it seems I noticed that I've gone back. A couple of people had questions about right tack. Was I still talking when I explained what the right tack was for? Matt, can you please confirm? I'm so sorry. I'm making a hash out of this. I hope the content is worthwhile. For the technical issues I've been giving myself. So I'll until I get confirmation or disconfirmation about whether I was still talking, I'll continue on about sane indexing. Yeah. So it looks like, it really mirrors this thing you learn quite early on, but it gives you a high rank version of selecting using the indices of ones in an equivalent Boolean mask, along the first axis. Sorry, that was a bit of a word sandwich. Hopefully this clarifies what I mean, right? Quite early on, you'll learn to select from a vector using a vector, and that you can do action by compressing with a Boolean. And this comes into one of the first sort of array-oriented things you learn, which is replacing your procedural if-then-else type logic with, logical functions applied between whole arrays of arguments, and then using that result, which will be a Boolean matrix, to select from arrays. So then that's that branchless logic of APL. So sane indexing is sane, I guess, and also rank polymorphic, which is a fancy way of saying it works for arrays of any rank. So this is vectors or matrices. I cut out halfway through the tack. I am echoey. Echoey. I should re-explain the tack briefly. Okay, apologies for this. The right tack in this example separates out the argument array from the operands to rank. So I had a little thing here. I might just reconnection successful. I might just hopefully some or most of you saw all of that. If all of this technical mess is too disruptive, I'll keep doing this here so that you can ask questions and get more clarification. But if it turns out that it's too disruptive, I might just re-record this at some point. I'm not sure, because OBS was telling me it just disconnected. I'm so sorry. That was the right tack. This is sane indexing. It's related in some sense to something you learn really early on in APL, but it gives you a single construct a single function that you can use on arrays of any rank. Yep. So then, recently-ish, I've discovered this function, which called select, or I was calling it the indexer, and this allows you to do sane indexing. But it also, and in the simplest case, with a scalar index, it works the same as all of these other constructs. Just give me the first major cell, or the nth major cell, or the nth subarray along the first axis, if that's how you want to phrase it. But it also lets me select disparate cells of any rank in the array. So in this case, I'm choosing the second row of the first matrix and the third row of the second matrix, all in a single statement, which is quite convenient. I had a little play to see if I could, what was the most succinct way I could express this with square brackets, and this is what I came up with, which is choose indexing, where I've manually constructed the whole set of indices. If anyone who's watching now or in the future thinks of a nicer way to do this with square brackets or any other without the indexer, then please let me know. I'd be interested to see that. Not only, the things that you select don't even have to be the same rank, when you choose them, which is really nice. Okay, so here I'm selecting a scalar and a vector, and they get mixed into a matrix in my result, and the first row is padded with spaces, so there's 3 spaces up here. So that's something to just be aware of if you use this, but it's something quite useful, or it's a neat little construct for doing this type of choosing, but not just scalars. And the rule for it is this. So if the array I'm indexing into has a rank R, and I want to select rank K cells, then the index I use has a length of R minus K. Right? So you can see that in the orange index here. It has a length 3, and I'm selecting a scalar, and the blue index here has a length of 2, and I'm selecting a vector. So that's the indexer. It also happens to be, and I didn't know this until recently, it happens to be one of the behaviors of the from verb in J. So if that's any argument for calling this modern APL a modern construct, then I guess that's it. Between this and squad, we get 2 of the behaviors of from, and then there's one other which I haven't got a nice function for, but I'll leave that as an exercise for the viewer. Right. Winding down now, let's look at a couple of last squad with rank functions. Here is one I'm dubbing choose, and it's squad rank 199, where you get choose indexing without square brackets, which for some people is like a style thing they care about. Ultimately, it's up to the user. Do what you want. For the small price, you can get choose indexing using without square brackets for the small price of mixing your index, or mixing your indices, or indexing with a matrix where each row is a full index into our argument array. There's also squad rank 99k, which I'm dubbing cells for the sake of this webinar. Don't know if there is a proper other name for it. But this is like, give me the k minus 1 cells. But obviously squad is squad, so you can give multiple. If you give a longer argument on the left, then you're going down in the ranks, like we showed with simple indexing at the beginning. But you can kind of simple index into a specified rank of your argument array. But of course, and remember, it's not choosing, right? You'll loop over all of the rank k arrays. Okay. So yeah, as I said, you can go deeper into each of those, but ultimately it's a loop over both of the 2 cells and doing squad like that. So sometimes, this might be the way you think of doing it, right? This is all about offering, there are straightforward ways of doing any kind of indexing. There are the types of indexing I explained all at the beginning. But here we're offering more options for potentially more convenient ways of indexing that, just might feel right in particular situations. I can't really give you loads of details on when that's exactly going to be, because indexing is so fundamental to APL, you do it literally all the time. So selecting from arrays, we've seen the squiggles, the glyphs, the symbols that you use to access different subarrays and cells, and the scalars. We've seen Sane indexing. We've seen the indexer. We've seen choose indexing, and this one called cells. And it's worth noting that the square bracket indexing constructs and their equivalent expressions using plain squad are optimized. They're going to be quite fast. This indexer, despite being fairly convenient, is going to loop overall of your indices. So, it will suffer in terms of performance. For the other ones, before version 18, and I'm supposing since version 14, when rank was introduced, squad rank 0k has been optimized. So that includes Sane indexing and squad rank K with a scalar left argument that we've seen before. New, coming in version 18, released this year, the choose squad rank 199 and also the cells construct are going to be optimized. And that last one means that any squad rank K for any K will be optimized, provided that you use a left argument that is a vector. So that's the notes on performance. And so as well as performance considerations, you also, should be aware that things like indexed assignment don't work with rank. If you want to know more about how indexed assignment works, you can search it in the help. There's something else I thought just to mention quickly. It's not indexing, it's called selective assignment. Any way that you can select subarrays or elements from arrays, and this is apart from indexing, although you notice that index is listed here, you can use that to modify an array in place as well. So yeah, search again on the help if you want more info on there. I also wanted to, not in too much detail, but just mention @, which is kind of related as well, but it doesn't modify your array in place. It's more geared towards functional style, so arguments in, argument out, no in place state modification. You can either provide indices in the sort of choose fashion, or you can use a function which returns a Boolean array when applied to the argument, and use that to select. And you can also apply functions at particular indices. That's why @ is super convenient. So that's my kind of overview, introduction, and a bit more on selecting from arrays. I'm now sort of going to give you a couple minutes. Apologise for all the technical hoo-has that happened during this. If anyone has any further comments or questions, so I'll give you 2 minutes. Maybe I'll play some inoffensive music while Matt confirms or denies. Whether there's any more comments. Matt is typing. Okay, considering that we had, a question in the middle, hopefully my explanation of that got through somewhere in the video, and that was clarified. Otherwise, thank you very much for watching. In this sort of lockdown times, between Dyalog and the British APL Association, there are weekly webinars going on at the moment. The next one is next Thursday. It'll be, I believe, Michael Hughes from MJH Software Services introducing QWC, that's cross-platform Quad WC graphical user interfaces, Alpha 0.4. And that's going to be a Zoom meeting, so for more details, if you want to know how to join that, you can go to the British APL Association website. And the week after that is the next Dyalog webinar. Same time, the next Thursday after next. I don't know if my Curtis Jones, do you play guitar left-handed? I don't know. It's possible the camera's being mirrored. Because I don't. I play right-handed. So yes, the next 2 weeks' time, Dyalog.tv again. Morten Kronberg will be introducing Dyalog version 18. You saw a couple extra performance enhancements from today. Otherwise, yeah. Thank you all very much for watching. Maybe I'll go hang out in the chat just now for a moment. See you next time. Bye.